Yeah. My name is Joonas Merikanto and I work at the Finnish Meteorological Institute. I do global modeling of climate. So global models are a very important tool to understand what is going on with the climate and how it's going to change in the future. So I'm going to talk a bit about the basics, why the climate is changing, and then about the impacts, what it's causing. So first to the basics. Climate is a complicated system. So it involves the energy from the sun, and then the flow of energy between the atmosphere, the ocean, and the land, and also gases, momentum, heat, so forth. And we need to understand all of these components to understand climate. And I'm the one responsible for putting this in a global model as well. But when it comes to climate change, it all boils down to this Earth's energy budget. All of the energy that heats our planet comes from the sun. Other sources are minor. The sun is the major one. And about 340 watts per square meter, if you average around the globe, comes from the sun. But if you look at the energy that hits the surface, it's actually much more. It's at 342 plus 161. So it's way more than what is coming from the sun. And why is that? Actually, the energy that originates from the sun starts to loop in the atmosphere. And it loops there because of greenhouse gases, such as water vapor and carbon dioxide. So, greenhouse effect is a very natural effect, and it's good for the planet. It actually heats the planet by 32 kelvins or Celsius, which means that if we wouldn't have it, our Earth would be completely frozen. So, but what is going on? That now, because of the human activities, here's year number 0. Somebody called Jesus might have walked the Earth around that time, and then there's the modern times. The greenhouse gas concentrations, such as carbon dioxide, stayed very constant through the history until the Industrial Revolution hit. And then they started climbing up. And now the concentration of the carbon dioxide, when it started from 280, sort of, parts per million, now it's over 400. And the increase of these greenhouse gases is causing the planet to heat up. It shows basically that if you look at the evolution of the temperatures of the climate from the 1880 to this date, you can see that the planet has already heated up by around 1 degree, and the 5 warmest years in our history have been the 5 past years from 2014 onwards. This shows that the regional distribution of the temperature change is not constant around the world. So it's not just that the planet is heating by, say, 1-2 degrees globally, but the continents are heating more rapidly, and especially the Arctic area is heating way more rapidly than the whole globe. Now the Arctic area is warming really fast, around 2 to 3 times faster than the global average. One of the consequences of this warming is that the Greenland is now starting to melt quite rapidly. So here's the melting rate in 2003, melting rate at 2013. It has increased 4-fold. Now the Greenland is melting at the rate that in 1 year you could fill up the whole Finland to my hip level with fresh water. If you then calculate the melting from the Antarctic as well, you would be soaked completely in the water throughout Finland. So it's quite scary. What this does rises the sea level globally. And now we have had to revise these estimates of the sea level rise quite much in the last years. This is from the American colleagues from 2017. It shows that with this rate, if we keep on warming the planet as we do at the moment, the sea level might, not necessarily, but might rise by 2.5 meters by the end of the century. And it's quite amazing. I think most of our populations are based on the coastal areas. Good thing about this, actually, go back, it might only rise by 30 centimeters. And that's something we can live with. One of the other consequences, remember that the Arctic is warming quite rapidly now. This basically means that we will lose at least around 40% of the permafrost in the Arctic area by, say, 2040, 2050 already. And there's lots of carbon in the permafrost. More than those carbon in the atmosphere is stored in the Arctic permafrost. And it's a pretty scary thing because we don't know what's going to happen to that carbon. Another one of these consequences, this is from the Arctic Sea. The permafrost is melting. This caused the coastline to erode to the sea. In some places it's 20 meters per year erosion of the coastline at the moment. Climate change is really not just about the global temperature rise. It's also changing our weather patterns. And one of the things that happens when the pole is warming more rapidly than the equator is that the energy flux gets stagnated from here to here, the normal energy flux. And it means that also the weather patterns that normally take place get stagnated. So we can have very, very long spells of cold weather or warm weather, and this becomes more typical as the planet warms. So it causes heat waves. It can also cause cold waves. So this report from the International Climate Panel came just last autumn, and it studied the consequences of what happens if the planet warms by more than 1.5 degrees, and what needs to be done to keep the warming to 1.5 degrees. And now we're already at 1. The report is saying that we can still limit the warming to 1.5. It is technically possible, but without any limitations, our planet will warm by roughly about 5 degrees by the end of the century if we keep on emitting as we are at the moment. And already, if you go a bit above 1.5, well, you see temporal damage from extreme weather. Remember the stagnated weather patterns. Also hurricanes get stronger. Then you have heat-related health impacts. Mortality rates will rise. Some places might become almost uninhabitable. The seas are suffering. The sea biota. Irreversible damage, say coral reefs. We might lose all of our coral reefs if we warm by more than 1.5. That can happen in 20, 30 years. All of them are dead. Extinction of species. This will certainly happen if we go to 5 degrees. We will have a mass extinction. And then melting of glaciers and the sea level rise. So, in order to keep the temperatures to less than 1.5, well, the warming to less than 1.5, we need, this is our emission rate at the moment. Again, the global emissions rose by around 2% last year. But what needs to be done is to go to 0 by 2050. Negative after that. It's a massive change. And this is required if we want to keep it, if we want to keep the planet safe. I thank you with this, and I welcome questions if I have.
We might go for some questions afterwards. We've got some other speakers covered. Thank you so much for the who's excited about climate change?